Hi guys, I am back again. On this lecture, number 6 of the series of equations, I am going to talk about two things: elimination method and substitution method. And we're going to start with elimination method. So this chapter is simultaneous. Simultaneous equations. Simultaneous equations. Okay. Simultaneous equation is when we have two systems of equations and we want to solve for the unknown variables simultaneously for both equations. That is why we end up with this method. There is the first method that I'm going to talk about. One is elimination. Number 2 is substitution. Substitution. Okay. I'm just going to take an example and explain the principles. Here you must get the principles. You know, these simultaneous equations, I like this system. We use a lot of simultaneous equations when we do, for instance, mathematical modeling for economics, when you do economics, you find that you are solving multiple, maybe 20 equations at the same time. And when we do that, we use a matrix system. We use matrices. It's a very interesting thing. This is where it starts. Very interesting. You do things that are far beyond human imagination. Alright, so I am starting with the elimination system, elimination method. I have this example. So this is 2x plus y equal to 12. My pen is not writing well. Don't know why. Nevertheless, I'll be patient. 2x plus y is equals to 12. And 5x plus y equals to 21. This is how they present these equations. this is how they present them. This is their standard form, you know. And let us organize these equations. We are going to have this first equation, and it's important for us to label them as equation number 1 and equation number 2. So we're going to call this 1. And then we're going to call this 2. Alright. What is the next step? We need to subtract equation 1 from 2 or equation 2 from 1. Whatever we want to do, it does not matter. So I decide to take equation 2 and subtract equation 1. So in doing so, we have 5x plus y equal to 21. Subtract. So we open the brackets, we're subtracting 2x plus y is equals to 12. So this one, I want to explain it. You can see this is a distributive property. This is a distributive property. It's important for you to understand all the properties, the laws, so that you can be able to identify them. I am able to identify them all the way. If you reach that position in your life whereby you can actually see the characteristics of the equations or algebraic expressions, you see the laws, you see all the structures, you see all the formats that we've learned, you see all the properties, you are in the right way, right direction. Negative 2x. So we take this negative and multiply here and multiply here, it becomes positive, it becomes negative. So we applying, then it means we're applying a distributive property. Let me do this. I'm going to put it on the side. Here we're going to have negative 2x, negative 2x, subtract y, not plus, because we now multiply. Subtract y equals to negative 12. This is negative 12. It's not clear. Let me do this. A negative 12. So here we have 3x. Here we have 0 equals to 9. So x is equals to 3. And we call this equation 3. We call it equation 3 because it's the third. the first, the second, the third, not because x is equal to 3. It's not related. It's not related to that at all. We can have here x equal to 7 and still call it equation number 3 because it's the third equation. We take the third equation and we substitute on one of the above equations. You can choose to substitute on equation 1. Okay, let's take equation 1. It looks simple. It just got small numbers. So we take 3 and into 1. We substitute into equation 1. Alright, we have 2x plus y is equal to 12. And then we're going to substitute 3 plus y equals to 12. Y is equals to 6. So we have a point of intersection. A point of intersection. We know the coordinates is x map y, and therefore we have 3 map 6. Here we had 2 equations. We solved them simultaneously using elimination method. At the end of the day, we found the solutions for x and y. We can plot these points on the Cartesian plane. These points are actually called intersection point. In economics, this is equilibrium point, okay? Yeah. Is a point of intersection. It is equilibrium point. I've forgotten something else I wanted to mention. Yeah, that is it. The next is a substitution method. A substitution method, you just make sure that equations substitution method is usually used when you've got 2 different equations, in a sense that you cannot do elimination. So I want to use a specific equation. I'm going to take a linear equation and a quadratic equation. Substitution. substitution. We have x plus 2y equals to 1. We call it 1. And then we have, okay, this is a nonlinear function, nonlinear equation, I mean. This is nonlinear. So, there is something that we need to do here. I need to take one equation and set it such that one variable becomes the subject of the equation. I decide to transform 1. I'm going to transform 1. I'm going to change 1. X will be equals to 1 subtract 2y. Okay. And then I call this equation 3. Alright. Why is this 2 looking like a Z? This 2 is looking like a Z. And this X, I don't like it. Right, where my X? I'm telling you. Better. Okay. Now, I will substitute 3 into the nonlinear equation. We have x squared plus 4y squared equal to 41 equals to 41. So x squared plus, oh, I must substitute by the value of x. We must substitute here. X is equals to 1 minus 2. 1 subtract 2y all squared plus 4y squared equals to 41. I actually have no intention of resolving this. We dealt with these things. Here we spoke about product formulas. So you remember the product formulas. You are going to resolve this yourself. What I'm going to give you are the final answers. Here you need to solve for y and take the value of y and substitute in one of the original equations. You can even substitute it on equation number 3. It's the easiest. So the value of y, we're going to get a value of y equals to -2, or y equals to a 5/2. A 5/2. And then you substitute. And then x, you will get x, you substitute with this value -2 on this equation. You are going to get x equals to 5, or you're going to get x equal to -4. Therefore, it means our points of intersection, there's 2 of them, is 5 map -2, and this looks bad. I'm going to write it nice. Five map -2. And the other one is -4 map 5/2. What does this tell us? It means that the straight line x plus 2y equal to 1 cuts or intersects this nonlinear equation, x squared plus 4y squared equal to 41, into, these two. There are 2 intersection points. There are 2 points where these functions meet, these lines, because we're still going to do functions. You will see this graphically. For now, you must understand these are intersection points, these are equilibrium points. The importance of this is that we are able to solve systems of equations simultaneously. We have 2 methods. The first method is called a substitution method, where you just take one equation and subtract it from the other equation. Here, you do a substitution method. You substitute. That's it. As easy as that. But you may also find that you can make 2 equations equal to a similar variable, and in that way you'll just equate the 2 expressions. Let me just do that. Oops, there's work here. Alright, let me delete. What I am doing is still part of the substitution method, okay? The first method is the one where you have equations that are not similar in terms of their properties. So I'm proceeding with the second method of the substitution. Here we have 4x plus 8y equals to 36. And then you have 2x plus 9y equals to 28. So this is equation 1, this is equation 2. I'm going to take equation 1 and sort it out and make x subject of the equation. So we have 4x equals to 36, subtract 8y. Therefore we end up with x equals to 9 minus 2y. We call this equation number 3. I also take equation number 2 we're changing them. I'm going to do the same thing. (28) subtract 9y, x is equals to 2. So the substitution method, you are going to take the value of x is equals to 9 subtract 2y. So the easiest thing from now you have your 2y, you have your 2x, so you will substitute, as we call it substitution. We are going to substitute in place of x, we are going to put 9 subtract 2y is equals to 28 minus 9. You solve for y. After finding the value for y, you solve for x, and then you specify the points of intersection. This is it. We're done. We're done. We substitute. We've done it. So on this method you follow the same method that I've done on this slide. Here it looks exactly the same. Thank you guys. Please like my page, like my video, share my video with your friends, just distribute it to everybody that you know. It must spread around.